Hello and welcome. Here we are doing question 2 where we are given a part A and part B. For now we will just focus on part A, where we're given an arithmetic sequence where the first term is equal to 0.6 and our fourth term is equal to 0.15. For our question, we're asked to find the common difference, D. And to solve this question, first, we know that in an arithmetic sequence, the nth term, denoted as un, can be given by the following formula. So we can see that we're given both the first term as well as the fourth term, where the first term will be substituted here, and we will use the formula to evaluate the fourth term and solve for d. So we have to let n equal 4 and then substitute into our equation. Formulaically, it would look something like this. And then when we substitute our values, it will look like this. We'll rearrange the equation so that we can isolate for d. After rearranging, we'll have to do some calculations. And finally, we can isolate for d by dividing both sides by 3. And when we evaluate this fraction, we can finally see that the common difference, d, is equal to negative 0.15. And that's our answer for part A, question A, as well. Now we continue the question on to part B, where we're given a probability distribution table below. Okay. And we are asked to find the value of k, where k is the value that gives us the probability of an event occurring at some integer n, where for some value in our arithmetic sequence that is at n is divided by k. In this case, we have n equals 1, 2, 3, and 4. We have 4 values in our sequence. We also have to use the fact that the sum of each probability within a distribution is equal to 1. We can evaluate and then isolate for k. So from question 1 as well as the table right here, we know that we have p at x is equal to 1 as well as p at x is equal to 4, but we're still missing the values for the numbers in the sequence for n equals 2 and n equals 3. And so we have to use the equation for any nth term in an arithmetic formula to evaluate n equals 2 and n is equal to 3. Where if we recall from before, the formula is given by the following, and that we calculated for the common difference, which is d, which is equal to negative 0.15. So if we start with our second value in the sequence, and then substitute our values into the equation, it should look something like this here. And after calculating, you should find that your value is 0.45. And we will do the same for our third term, which should look like this here and give you the value of 0.3. Now that we know u2 is 0.45 and u3 is 0.3, we can write out our respective probabilities, like so. And now we can finally use the fact that the sum of all the probabilities within this distribution should equal to 1. So if we rewrite this in terms of the actual probabilities, it should look like this here. Okay. And then since all of our terms here have a common denominator, we can combine them. And after combining them, we'll see that 1.5 over k is equal to 1. So k is equal to 1.5. And that is our answer for part B, question B.